Ever wondered how AI is turning text into videos that feel almost real? Let's break down the science behind these breakthroughs and why they're a big deal. At the heart of this revolution are diffusion models, a type of AI that works like a digital, reverse engineering process. Imagine adding random noise to a photo until it's just static, then teaching the AI to undo that noise step by step. That's how these models generate everything from images to videos. But here's the twist. Researchers are now making this process faster, smarter, and more consistent than ever. Take Timestep Embedding, a technique that's like teaching the AI to remember the timing of each frame in a video. By caching key steps in the process, it avoids redundant calculations, slashing processing time. Or check out Phantom, which uses cross-modal alignment to keep characters or objects consistent across a video, even when the scene changes. It's like giving the AI a memory of what it's supposed to look like. And then there's the race to make diffusion models lightning fast. Papers like DPM-Solver and InstaFlow show how AI can now generate high-quality images or videos in just a few steps. Think of it as skipping the boring parts of a recipe to get straight to the delicious outcome. Meanwhile, techniques like learning to cache and training-free diffusion acceleration are making these models run on regular computers, not just supercomputers. But the real game changer: consistency models. Unlike older methods that relied on guesswork, these models use mathematical equations to ensure every frame in a video flows smoothly. It's like giving the AI a roadmap instead of a GPS with no signal. What does this mean for you? Imagine creating a 10-minute video in minutes, or animating a portrait with just a voice clip. These advances are making AI not just powerful, but practical. And as researchers keep refining these techniques, the line between human-created and AI-generated content is blurring fast. So next time you see a viral AI video, remember, it's not magic. It's math, creativity, and a whole lot of clever problem-solving. Stay curious, and let's keep exploring the future of AI together. But there's another approach driving AI video innovation: generative adversarial networks, or GANs. Think of them as a creative duel, two neural networks locked in a battle. One, the generator, tries to craft videos that look real, while the other, the discriminator, acts as a critic, sniffing out fakes. Over time, this back and forth hones the generator's skills, like a painter getting better by constantly comparing their work to the real thing. But here's the twist: this team isn't just making 5-second clips. They're aiming for full-minute videos. That's a huge leap, because longer videos require continuity. The same character can't suddenly flicker out of existence, or the camera can't jump around like a glitchy VHS. To tackle this, they tweak their training process with some clever tricks. First, they borrowed techniques from earlier AI research. Consistency distillation helps the model learn from its own mistakes, like a student reviewing their work to spot errors. Diffusion adaptation slowly refines videos, kind of like how a sculptor chisels away at a block of marble. Then came their own innovation: a relativistic pairing loss, a way for the discriminator to compare generated videos to each other, not just to real ones. This helps it catch subtle flaws, like a shadow that doesn't quite match the lighting. Training a model to handle long videos is like teaching a toddler to ride a bike while juggling. The researchers solved this with a method called long video extension training. They started with short clips, 5-10 seconds, and gradually stretched them out, overlapping parts to keep transitions smooth. Imagine stretching a rubber band, pulling it bit by bit to avoid snapping. They also adjusted parameters like the learning rate and batch size to keep the model from getting confused as the videos grew longer. Here's another cool trick: result recycling. The AI reuses its own previous outputs as inputs for the next steps, like a painter using earlier brushstrokes to guide the next. Without this, videos would look jumpy and incoherent. They even tested what happens if they mask these recycled results. Spoiler: the videos turn into a mess. They also experimented with how the model learns. Teacher forcing, using real video frames as input, didn't work as well as student forcing, letting the AI rely on its own generated frames. Why? Because small errors in predictions add up over time, like trying to follow a recipe by memory, where one wrong measurement ruins the whole dish. The results? Their model outperformed others in metrics like temporal quality, how smooth the video feels, and motion consistency. It even adapts to different resolutions, and they optimized it to run faster by simplifying parts of the neural network. Think of it as a lightweight version of a video compression tool. But here's the catch: the videos still have flaws. Shadows might flicker, or camera movements could feel stiff. Yet these are the growing pains of a field racing toward perfection. The takeaway: AI isn't just mimicking reality, it's rewriting the rules of creation. And as these models get smarter, the question isn't if they'll replace human artists, but how they'll collaborate with them. So next time you watch an AI-generated video, ask yourself, is this a glimpse of the future or just the beginning? The answer lies in the math and the imagination of the people building it. Stay curious, and let's keep pushing the boundaries of what's possible.